Hello, let's do the New York Times Hard Sudoku for March 8th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I do have two 8s looking into this box, and this 8 looks up, so 8's in one of these two cells. I also have two 5s looking into this box. This 5 doesn't really help, so 5's still just in one of these two. Something must be going on over here. There's 4 digits left. Sometimes the easiest thing is just thinking about what the 4 digits are. We need a 4, 6, 7, and 9. So I'm seeing this 4 look in. So 4 is in one of these two. And this 9 looks in. So 9's in one of these two. So at the very least, if you just count, this one is down to 2 digits. And I think it is going to be 2 digits as candidates. Because, you know, if you count, there's only 9 total digits. Here's 5 of them. And then the 4 and the 9 bring it to 7. 9 minus 7 is 2. So there's going to be 2. It's always good to be thinking about that in your head because it's really easy to make human error when penciling. So if I'm expecting 2 digits and I get not 2, then that's something to double check. So we can't be 1, 2, 3, 4, 5. We can be 6. We can be 7. We can't be 8 or 9. There you go. We did end up with 2. Just thought I'd throw that little tidbit in there. There's 4 digits left in here as well, which I'm going to think about. We need I'm already seeing the 1 and the 2 here, but let's just the 2 is not useful, but the 2 is useful for the middle box. It's one of these two. Anyway, I'm getting sidetracked. I'm seeing this 1 here. I'm seeing this 7 here. So actually, yeah. But let's think about the exact digits we need. We need 1, 5, 7, 9. 1, 5, 7, 9. So I'm seeing a lot of usefulness here. We're going to get 2 digits at least. So first of all, we need 1 and 7. This 1, 7 tells it it's not in these 2 cells. They're not here either. So there's only 2 cells left that can be 1 or 7 in this box. Those are these 2. We need 2 cells for 1, 7. There are only 2 cells for 1, 7. Therefore, those 2 cells have 1, 7. Now, excuse me. Coughing in the middle of a train of thought is the worst. Anyway, there are 2 digits left in this box to place. The 5 is one of them, and this 5 tells us that it can't go here. So this is a 5, and then the last one's a 9. Now that 9 looks up. It removes one of our 9 corner marks. Remember, the corner marks were telling us that there were only 2 places left in the box for that digit? Well, one of them got removed, so now there's only 1 place left in the box for that digit. So that's where it goes. So we can just place the 9 there. I didn't mean to remove that 9. I was in the wrong mode. And so we have 4, 6, 7 left. When it's 3 left in a box, especially in like an isolated box like this, sorry if I can type correctly, 4, 6, 7. I like to just pencil it up. I think that's perfectly reasonable. All right. So we just got a bunch of stuff, and we didn't really finish completely scanning, I don't think. Although here, yeah, okay. So we got this 9. So these 9s look in. There is a 9 one of these 3. The only time I'll mark 3 in a box is if they're all in a row, because that kind of reminds me that it's in that row. Your mileage may vary. I completely understand people who do not want to mark that. I just think it's nice that it updates to 2 when we eliminate one of them. And then 2 is always useful. Okay, anyway, I'm thinking this stack is going to be very useful because we have 2 almost complete boxes. So let's just go through that. So we have these 9s looking down. So 9's in one of these 2. Maybe I should just go in order. So 1s we can't do much with. 2s, we do have 2 2s, and then this 2 as well. So 2's in one of these 2. We do have 2 3s, and they join the 2s. So these 2 3s look down. This 3 looks in. The exact same 2 cells that we marked 2 in, we're marking 3 in as well. And we didn't mark them anywhere else. That's important, right? If we had like a stray 2 or 3 over here, it wouldn't work. Or even just here, it wouldn't work. Even just a single one. But what this is telling us is 2 wants to be in exactly one of these 2 cells, and 3 wants to be in exactly one of these 2 cells, the same 2. So that's the same situation that we had with this 1, 7. There are only 2 cells in this box that can be 2, 3. So those are the 2 cells that must be 2, 3 and nothing else. So now we have a 2, 3 pair in this column. We know that 1, 6, 7 are the remaining digits. We can just fill that here as center marks. If we can get in the correct mode at least. Okay, so that was 1, 2, 3. Let's look at 4s. Okay, I'm not seeing anything to do with 4s. Let's look at the 5s. These 5s look down. This 5 looks in. So there's a 5 in one of these 2. This is a really interesting pattern with the 2, 3, 5, 8, by the way. It's kind of limiting a bunch of stuff to this. So this is the exact situation I just talked about. This is not a hidden pair. Just because 5 and 9 are cornered in here and here does not mean it's a hidden 5, 9 pair, because the 9 can escape here. We can put, like, I can put like a, let's do an example. I can put like a 4 here, and that's perfectly fine because I can do 5, 9. That's one way this could resolve. And so if this 9 were to get eliminated, then if I put a 4 here, then this one needs to be both 5 and 9, and that's broken. So do be careful about that. But it is nice to know that 5's in one of these two. How about the 6s? 6s are no good. 7s we don't know anything about. And then 8s and 9s. So I know the 8s will be nice because there's an 8 here. So these two 8s look down, this 8 looks in. There's an 8 in one of these two. And then the 9s we already have marked. Okay, so this middle cell avoided a decent number of pencil marks. Basically what we know is it can't be 2, 3, 5, 8, and it can't be 2, 3, 5, 9. So unfortunately that's a lot of overlap. So it's 2, 3, 5, 8, 9. 2, 3, 5, 8, 9. That's 5 digits, so there will be 4 digits left this can be, so that's not super helpful. So we're not going to mark that. You can do this counting in your head pretty quickly and get a feel for what to mark and what not to. I'm noticing these two 7s. If I notice something, I'll do it, even if it's out of order. Okay, so I did that stack. I kind of want to look at this band again, just to make sure I didn't miss anything. Yeah, so the 1-7 pair takes 7 out of these, and this 7 takes 7 out of these. So 7 ends up down here. And then the 1-7 pair takes 1 out of these, and this 1 takes 1 out of these. So there's a 1 down here. This is prime for crossings. So our candidates to cross, because we're basically looking over here, our candidates to cross this are 3, 4, and 6. So what we want to do is we want to look over here for 3, 4s, and 6s. Unfortunately, there's nothing, so we don't actually get any crossings. The 2 doesn't work because there's already a 2 in the box. This is prime for crossings as well, the 2, but we already marked the 2 in this box, and we didn't cross. So I don't think there's anything there. The last thing I'm interested in, well, not last thing, but the next thing I'm interested in is this band, this bottom band here. We already took care of this box pretty well. We go in through every number. This 7 is looking in here, putting a 7 in one of these two. And that is something that we didn't necessarily account for, is that these 7s now point into here. So because the 7 is over here in this box says 7 is in row 9. Row 9 can't have another 7 in it. So these aren't 7. This 7 says these aren't 7s. We could pencil mark 7s across here. I guess we should. Not should, but I guess I will. So that was the 7. There's not really much else to do here. Am I going to think about what we need here? No, I'm not, because the 1, 2, and 8 are already in the box. We already took care of the 7. That's really it. There's nothing to see. So we do have this 1, 2, and this 1, 2 here. And had I noticed that earlier, that would have been very nice, because that's really powerful. So notice the 1, 2, and the 1, 2 take 1 and 2 out of here. This is not 1 or 2. So this ends up another hidden pair. 1 and 2 have to go here, but we do have this 1 that actually tells us the order as well. So the 1 can actually only go there, and then that's the 2. Now let's follow up on the 1 and the 2. The 2 especially, these two 2s look into here. So 2's in one of these 3. The 1s look into here, and that puts a 1 in one of these 2. So I guess the 1s and the 2s are about the same. The 5 and the 5. Okay, so this 5 looks down, this 5 looks in. That does put 5 in one of these 2. This is kind of the least interesting way to mark 2 in a box, but it still can be useful, because if one of them gets eliminated, you can place the other. And also, once you get to more advanced techniques, you can start doing some interesting stuff with that, but we're not going to need to in this puzzle. We do have 2 8s here, and this 8 and this 8. So 8 is actually placed in this box. Nice. Okay, so now I'm noticing something interesting. Yeah, for sure. So the question I want to ask is, where does 7 go in this column? And what prompted me to ask that question? Well, I'm seeing 7 is limited to these two, columns 7 and 9, in box 9, and in box 6, 7 is also limited to 7 and 9. So the question is, poor column 8, where's this going to get its 7? Well, there's only one box left to give it a 7, so it will. So 7 ends up in one of these 3. Not immediately useful. I'm noticing this cell here is avoiding it's avoiding these. Like, it's not 1, 2, 8. It's also not 5, 7, 9. 1, 2, 8, 5, 7, 9. That's 6 distinct digits. I'm also noticing it can't be 3. I'm also noticing it can't be 5. Oh, sorry, 5 was already mentioned. So it might be 2 digits. I think we're expecting 2. So it can't be 1, 2, 3. It could be 4. Can't be 5. Could be 6. And it shouldn't be able to be 7, 8, 9. Yeah, it can't be 7 for the reason we specified. The 7 is in this column, so it can't be also over here in this box, right? So that's a really interesting way of eliminating 7 from here. And so this is not 7, it's also not 8, and it's also not 9. So, or pick this 8 if you prefer. So we're down to 4, 6. That sounds really important, but I don't know how to use it yet. Okay, so let me make sure. I think I did this vertical scan. This vertical scan looks pretty done to me. Just double checking. Yeah. Looks pretty done to me. And then we just did this vertical scan. We got the 1 2s, we got the 8s. The 5s aren't super interesting, I don't think. Actually, yeah, this 5 looks in, this 5 looks up. So 5 ends up in one of these two. Even these lining up will tell you the same thing, that this row needs a 5, but it already has it in this box, right? So no action required. It has the 5. But I just thought I'd point that out, that this pattern is the same as this when it comes to boxes that are on top of each other or next to each other. Okay, so at this point, we have done the scanning that we can do, and we have not finished the puzzle. So what we want to do is we want to look for restricted cells. The very first thing I like to look for restricted cells are cells that are rows, columns, or boxes that have 4 or fewer open cells in them. Because by definition, they will only have 4 or fewer candidates. If we can get that down to 3, that just has to see one extra thing, that's worth marking. So this column, for example, has only 4 open cells. We need the 4, 5, 7, and 9. So this can't be 5. So this is 4, 7, 9. This can't be 7. So this is 5, 7, 9. Oh, sorry, 4, 5, 9. I said that very wrong. This is going to be any of 4, 5, 7, 9. Actually, it can't be 7 because these 7s point in. So this is actually 4, 5, 9. So 7 in this column is in 2 places, which is a little interesting. Keep an eye on that. If we eliminate either of these 7s, we get the other one. Okay, anywhere else 4 or fewer. This row. So the 1, 7 pair, you can kind of count those as done. They'll resolve one way or the other, but they don't affect these cells. Rather, these cells can't be 1, 7 either way. So these are going to be down to 4 digits at most. And I already see that we have this 1. Oh no, sorry, the 1 is already in the row. Okay, well, let's just see what we see. So 3, 4, 5, and 9 are needed in this row. This can't be 5, so this is 3, 4, 9. This can't be 3, so this is 4, 5, 9. This can't be 5, so this is 3, 4, 9. And I think this can be any of them. So that was really unfortunate. Everything was 3 or 4. So we keep looking. This row also has only 4 digits remaining. We need the 1, 5, 7, and 9. Both of these can't be 7. That's why we have the 7s marked over here. So these are down to 1, 5, 9, and this middle one can't be 5. I'm just going to write 1, 5, 9 though. I'm going to get rid of this 9. I'm going to get rid of this 5 here. And then these are 1, 5, 7, 9. None of them can be 1. So we're down to 5, 7, 9, and this one can't be 5. So let's write that out. 5, 7, 9. Get rid of the 5. Okay. There's 4 left in this row as well. So let's take a look at that. We need 2, 3, 4, and 6. Neither of these can be 2. So these are from 3, 4, 6, but it can be any of them. I think these are, oh, these can't be 6. So the 6 actually ends up over here, which may or may not be interesting. I missed these 2 6s when I scanned. It happens. These are from 2, 3, 4. Oops, 2, 3, 4. So this is really unfortunate that this band didn't like kind of resolve better on its own. But you know what happens. Kind of the worst case scenarios for 4 left in a row column box. Let's see. Did I miss any that are 4 or fewer? I already rejected this because basically there's nothing looking in that's useful other than the 7. And also it's 5 left. But sometimes I'll look at 5. So the next thing I want to look at these 2 cells because there's a bunch of corner marks in this box and they're all avoiding these. So we can just count in our head 1, 2, 5, 7, 8, 9. 1, 2, 5, 7, 8, 9. That's 6 digits. These are down to 3 at best. And if there's anything down here that's not accounted for in these corner marks, then that's going to be even more helpful. So they can't be 1, 2. They could be 3, but not this one, right? Only this one could be 3 of the 2. They can be 4, both of them. They can't be 5. They can be 6, but only the left one. This one sees a 6. And then they can't be 7. They're cornered here. They can't be 8. It's in the row. They can't be 9. It's in the box. So we found a naked single 4 right here. Just to double check, because whenever I find a naked single like that, I love to double check directly. So 1, 2, 3, it is a 4, 5, 6, 7, 8, 9. Perfect. It sees all of those digits. So it has to be a 4 because it can't be anything else and it's got to be a value. That's a naked single. That makes a 6, 7 pair here. We eliminated one of the 4s. So this is the 4. That eliminates 4 all the way down. Remember I said that 7 was in 2 places, and if I eliminate 1 7, I get the other? Well, guess what? We just got the other. So these are not 7s, and that's not 7. Okay, this 1, 6, 7 is not resolved. They're all different pi values. So we can't resolve that right now. Not directly, at least. This is a 5, 9 pair. Don't need the corner marks for a pair. These are going to be from 1, 4, 1, 4, 8, 9. 1, 4, no, not 9. I'm trying to find, 6. I missed 6. 1, 4, 6, 8. 1, 4, 6, 8. This one's not 8, so it's 1, 4, 6. This one's not 1, so this is 4, 6, 8. Okay, this one can be any of them. All right. I thought that might be more helpful than it was. This is from 3, 4, 5, 9. Is it any of them still? Yep. All right, where are we going now? What did we get? We got this 4. We got this 3, 6 bi value. Let's look at the rest of this row because it's down to 4 now, right? So we already conceived this. It's going to be the 3, the 6, the 7, and the 9, right? 3, 6, 7, 9. I think these can be any of those. That's really unfortunate. We only have 1, 2, 8s over here in like a singular 5. So we'd have to use the band. The band's got to get back together. All right. I don't know why. That joke doesn't even make sense. I just said the word band. Let's see. All right, I think we still just have to look for restricted cells. We might be looking for like a pair or something, or we could also be looking for claiming. One thing I like to do at this point is just double check, especially since I have so many corner marks, double check the corner marks, make sure I didn't extra center mark something. So like these 6s, I'm making sure I didn't mark 6 anywhere else. These 7s, I'm making sure I didn't mark 7 anywhere else. These 5s, etc. And just really quickly scanning the boxes to see if I have any stray marks that I shouldn't have put in. I'm also looking at our pairs, like this 1, 7 pair, and making sure that I didn't put 1, 7 elsewhere. 2, 3 pair, did I put 2, 3 elsewhere? 5, 9 pair, etc. It's all looking good though. So that's unfortunate. Sometimes it's just that. This row has 4 digits left, and I know that one of them is going to be limited over here because I can only account for 1, 4, 6 over here. So what's the other one? It's a 9. Right, so we can place 9 in this row. This 9 sees here. Whoops. This 9 sees here, and these 2 9s see down, right? So the only place in this row for 9 is right here, so that's where it is, and that's going to be extremely helpful. That's going to resolve most of this box because we get the 1 and the 5 here. We get the 9 here. That eliminates the 9. All right, maybe we're left with a 2, 3, 4. Anyway, that eliminates that 1 from here, getting this 1. So we get this one here. This is not a 5. That leaves a 7, 9 pair. This can't be 9. This is 3, 4, 6. I think we eliminated a 5 corner mark, so that 5 gets placed there. That also places the 5 here. Okay, that's good progress. We are down to, what is the first digit? 3, 6, 7 is what we're down to. Let's just mark that out. 3, 6, 7. Okay. What's our next step? Got this 7, 9. I got this 1. Okay, I didn't see how the 1 affects looking down, so it does put 1 in one of these two. Oh wait, no, sorry, we have 2 1s looking down. This one looks in. So it places this one. That now we can cascade some more. That's a 4. That's a 6. This is a 4. This is an 8. This is whatever the last digit is. A 1 looks like. We get our 7 and our 1. We get our 6 and our 7. We get our 3 here. We get our 6 and our 3 here. This is not a 3. 3 isn't one of these two. That actually points. Not in an interesting way though. All right, so that's not a 3. So 3 is in one of these two. Okay, so that points down. This 3 looks down. That puts 3 in one of these two. Now notice, sorry, I was going to say notice that these 3s line up. We do have the 3 in this row. In fact, this row's done. Is there anything else we can do with this? This is a triple, and we can note, the triple is our corner marks here, 2, 7, 8, and you can tell that this is the 2. So this is the 2, this is the 8, this is the 7. That places the 7 and the 9. This is a 4, 3, and 2. We get our 7, 6, 3, 9, 4. All of that's resolved. We get our 7 down here. This is 4 or 6. It can't be the 6, so that's 4, that's 6. All of these columns are done, I'm pretty sure, except maybe here. So 6 goes here. What's the rest? I'm just looking at what's missing in the columns. 9 is missing here. 5 and 9, we got those. This is probably a pair, actually. 3 and 4. Yeah, it is just a pair right now. But look at this, we're finishing. This digit should be useful, whatever it is. It's a 6. What are these two? Actually, I'm just gonna think about what the box needs because it's easier to scan a box than the whole column, especially because I have a really big window. So if I ever fail to scan like all the way up, it's because I have to like move my head to see it. Not the optimal setup. I don't recommend it, but I make it big for you guys so that you have a nice clear video of it. Anyway, we need a 2, 4, 5, and 8. 2, 4, 5, 8. So this 2 looks down. So 2's in one of these two. The 3 also is, oh, no, I don't need 3. I need 4. The 4 is in one of these two. We do need a 5. The 5 is placed here, which gives us the 2, which gives us 3 and 2, and 4 and 3 and 4. And our final digit is an 8. There we go. Took my time on that one as well. Hope that was helpful. There was some interesting stuff going on in this puzzle. I'm not sure what to recap exactly. We had several hidden pairs, like starting with this 1, 7, but we also got this 2, 3. We also got this 5, 9 at some point. We had quite a few hidden singles, of course. We had this naked single 4, which felt really important. We also had some other naked singles later, but yeah, I think there was some important pointing and claiming, like the 7s that claimed here probably was important. Things like that. Hope you enjoyed this. Hope it was informative. And if you did, then why don't leave a like, subscribe, and a kind comment below.